Hello class. Today we are going to discuss a method to quantify risk. Now we've used some other methods to look at risk, and this is from your book. It's a very interesting way to look at risk. It's called the William Fine method, and let's look at how it's used. It's a method for deciding two things. One, if the cost to correct a hazard is justified. Now this comes from our idea that safety always has to show a profit. So in other words, we have to demonstrate, if we want to get our program accepted, we have to demonstrate that what we do to prevent incidents happening costs us less than if the incidents did happen. So this is one method to do that, and it's actually quite simple, although at first it looks hard. We'll go through it step by step, and I think you'll enjoy it. Anyway, the first thing that the William Fine method does is it tells us whether or not the cost to correct the hazard is justified. And the second thing that it does, it talks about how quickly we should act to correct that hazard. So we get two pieces of information which are very vital for us by using the William Fine method. So the first thing that we do is we calculate a risk score. And the risk score is kind of a simple multiplication right here. It's R equals C times E times P. So it's just a simple multiplication. The only difficulty is in determining the values that we're going to use. We're going to look at those, but I kind of want to go through what they mean first, and then we'll look at the actual numbers that we might use. R, of course, is our risk score. That's what we'll get after we do our multiplication. C is the consequence. If the hazard actually turns into an accident, what might be the consequences? E is the exposure value. P is the likelihood that that hazard will cause an accident. So I will show you the values in a minute. All right, the second thing that we're going to calculate is the cost justification. So that means, again, like I explained, we have to show that the cost to fix the hazard will be less than the cost of the potential incidents caused by the hazard if we were just to do nothing about it at all. So here's how we calculate it. It's not a difficult calculation again, but we have to use the R value that we obtained in the first one. So J equals R divided by CF times DC. So J is our cost justification value. That's what we'll get after we finish our calculation. R is the risk score, and of course that's what we get up here when we finish our calculation. CF is how much it costs, essentially, to fix the hazard, and DC is the degree of correction. So that really means sometimes that we can correct something 100%, and sometimes we can just lower the odds that something bad will happen. If you look at page 2 of your handouts in this particular bunch, here are some values. And the values for each of these letters really indicate what number that you use for the calculation. For example, let's go back to our first one. R equals C times E times P. So our risk score equals the consequences which means these are the potential consequences of whatever the accident might be. For example, a tornado. Gosh, that might have some catastrophic consequences, mightn't it? Minor injury or damage, not so much. So these numbers right here are the numbers that we're going to use in our calculations. So the next factor is exposure. That's the E in our calculation over here. E is the frequency of occurrence of the hazard event. So does this hazard happen many times a day? Is it rare? Whatever. And again, these are the numbers that we're going to use in our calculations. Probability is the likelihood that when we have that hazard hanging around, that will actually result in an accident. And again, we have values, we have situations, and we assign numbers to them. CF is just the cost factor. So how much will it cost to ameliorate the hazard? And DC is the degree of correction. So here is the way that if we know these situations with our hazard in our facility, we can do a small calculation and learn if the cost to correct the hazard is justified and how quickly hazard should be corrected. All right, class, let's take an example. Let's see how we can do this calculation. So here's an example that I made up for you, and it actually pretty much exactly what's on page 661 in your text. So let me read it for you. A company is contemplating changing a process to reduce a hazard. The company has the following data about the change. If there is an accident, there will be multiple fatalities and more than $500,000 in damage. All right, the hazard event occurs once per year. There's a small chance, coincidental, that an accident sequence will follow to completion. The cost to correct the hazard is $60,000. The correction will reduce the hazard by 80%. All right, I think we have all that we need to do our calculation. So let's look at the risk score. First of all, we have, of course, R, which is what we're trying to calculate, equals, and the first one is C, consequence. Let's look up here. We have, looks like multiple fatalities and more than $500,000 in damage. Let's go over to C, and which value represents multiple fatalities, damage to 400,000 to 1 million. So that looks like our deal. Looks like 50 is what we need to put. So R equals 50. That's our first factor. Exposure, let's see, the hazard event occurs once per year. That's the frequency. So let's look once per month to once per year. That looks like our value, and that is 2. So we have 50 times 2. And then probability is a small chance coincidental. Let's find that here. Looks like right here. And that is 3. So 50 times 2 times 3. All right, if you do your calculation, R equals 300. All right, now we have our R value. Let's calculate cost justification. So we have J equals, and we have our R value already here, so that's 300 divided by, all right, let's look at our cost factor. We've got $60,000. Let's look over here. Oh, that's greater than 50,000. So it looks like we have 10 here times degree of correction. Looks like 80%. So let's look down here. Hazard reduced by at least 75. So that value is 2. 10 times 2. All right, so if we calculate that out, J equals 15. All right, now we've done our calculations. They weren't too hard, were they? Now, the next thing we need to do is find out what they mean. So we're going to go on to that right now. All right, now remember we asked 2 questions. One is the hazard worth fixing in terms of what kind of damage it could do? And the second one is how fast should we act? So let's look at the meaning of our risk score. And our risk score is 300 here. All right, what does that mean? Let's go to our page that describes the meaning. And let's find 300 on here. Okay, it looks like 300 is between 200 and 1500. And it looks like immediate action is required. So immediate action. That's kind of the highest level. We need to fix that pretty fast. And activity should be discontinued. In other words, stop the presses, stop everything, and fix whatever's going on. All right, so we know that this is really important. Okay, now the next thing we're going to look at is cost justification. And we have a value of 15 we got for our cost justification. This is a pretty simple one. If J is greater than 10, and then the cost is justified. If it's less than 10, it's not. So 15 is greater than 10. So it is the cost to fix the hazard is justified, and we have to act immediately. All right, I'm going to let you alone and let you do an example of this for credit. So please email me if you have any questions.